I'll introduce myself. My name is Alan Donatelli. I'm from the Chemical Engineering Department at the University of Massachusetts Lowell, and I have some help here today. Ken Lemba invited me to come here today. He's also a member of our Chemical Engineering Department. He's a professional technician in our department. He makes sure that all the laboratories run. And Janice Donatelli is my wife, and she's a microbiologist. Ken is a chemical engineer like I am, and as I mentioned, Janice is a microbiologist, a scientist. What we're going to do today is do a lot of fun things related to chemistry and biology. How many want to grow up to be a scientist or an engineer? Anybody here wants to be a scientist or an engineer? Great. Yeah, you can have a lot of fun doing stuff like that. What we do as chemical engineers is we make things that you use every day. We make things using chemicals. We make things by chemistry. We make things by using biology. And some of the things that you use every day are made by chemical engineers. Just think of the clothes that you wear. A lot of the foods that you eat are made by chemical engineers. All of this stuff here is made by chemical engineers. Everything that you deal with in life is a chemical of some sort. The clothes that you wear are chemicals. The food that you eat are chemicals. The air that you breathe are chemicals. Okay? So chemicals are good things, although you may hear some bad things about chemicals. One of the first things I want to do is do a fermentation reaction. Does anybody here make bread at home? Nobody makes bread. You know of anybody that makes bread? Okay. What they do is they use yeast. Okay? And what they do is they use yeast and they put it in the dough, and the yeast makes the bread rise. So we're going to do some type of experiment like that. And I'd like to have a couple of kids come up here and help me get started. Do I have a couple of volunteers?
Very shy.
You're going to help.
So nobody wants to help me, huh? Oh.
Sasha, can you come on up and help?
Sasha, come on. Just one question, and we don't need to do it. Be careful, okay? Be careful,
Okay. What I'd like you to do is boil the water. I need 2 cups of water poured into the Can you do that?
Next one, you come.
One more? Oh, okay, it's taking a little bit of time to go down.
That's all right.
Great. That's great, thank you. Let's see, now, here's some sugar. I need 4 tablespoons of sugar in there. Let me get a dry funnel. One, three, 4. Great. Okay. Next. This is some yeast. Now, what the sugar does, the sugar is food for the yeast. You know, you like to eat food, and that makes you grow and helps you provides you with a lot of energy. The same thing with yeast. The yeast needs something to eat so that it can grow and help the bread to rise. So I need 3 teaspoons of yeast. One, 2. Go a little bit more for good measure. It's close. Ooh. Thank you. Okay. Can we have the balloons? Oh.
Say that again? The balloons? Yeah.
Okay, now, what happens is that the yeast eats the sugar as food, and like people, when we eat food, we use some of it for energy, and then what our body doesn't use, we get rid of. Okay? So you go to the bathroom, you get rid of the waste. The yeast does the same thing. It eats the sugar, and what it doesn't use, it gives off, and this is what makes bread rise. You know what type of gas makes bread rise? Anybody have any idea?
Carbon dioxide.
Carbon?
Carbon dioxide.
Carbon dioxide, yes. So it takes a while for it to happen, because the yeast likes to eat the food at a certain temperature. It likes to eat it at body temperature. What's body temperature?
98.6.
98.6. Yeah, so when the yeast warms up, it eats this food a lot faster, and it digests it, and it gives off carbon dioxide. And hopefully, it will blow up this balloon. Okay? So we're just going to wait and see. It's going to take some time. Okay. What reaction?
They're really confused that you're gonna use the 160 mils of DI1, okay? What is the, is it a potassium sulfate? We'll go with the 160. Is that okay? And then, potassium sulfate.
This is potassium iodide, and sodium sulfate.
You got starch there? You got sodium?
Yeah,
I don't find starch.
you'll find starch.
Yeah, oh, that's right here. We weren't sure which one we're gonna do. We wanted to do 3, but we decided we're gonna do only 1 because we got a whole lot of stuff to do, so.
So, potassium sulfate.
Yeah, that's not shit, yours.
These 3 guys go here. like a magic show. We have the ionized water. Why don't you put the ionized water in this paper? This is a chemical called potassium iodide. This is a chemical called sodium thiosulfate. And this is starch. Mix that up.
If you see it, you gotta, oh, okay, yeah. Yeah, 1 minute, okay.
So this is the potassium persulfate.
Your job is to steer. Steer slowly, don't stop.
Okay. Now I'm going to take this. So we have 2 clear liquids here. Okay? Let's do it. 2 clear liquids.
You gotta stopwatch. Stopwatch. You gotta stopwatch, time it when you are on stopwatch. Wherever you are, take your clock and time it. See what's gonna happen and tell us. We wanna validate who is fast in timing. Just start the stopwatch. Start timing. Keep looking. It's gonna be a magic. I got 30 seconds before, I got 20 seconds, but I want to know what you're going to get, man. Keep time and keep watching. Are the kids watching? Is that a miracle is going to happen? You want to be a mad scientist. This is the time. This is real chemistry. Oh yeah, they're gonna get a eureka moment. You know the. If it doesn't work, we just gotta pack up and go back to UMass Law. What are you gonna do? Oh, so Doc, what actually happened?
What happened?
Yeah.
There are 3 chemical reactions going on over here. One with potassium iodide is converted into another chemical and goes kind of slow. And then there's another reaction that's very fast that takes the potassium iodide that was converted into triiodide ion, converts it back into an iodide ion. Now there's another reagent that heats up that triiodide and converts it back into an iodine. But when that reagent is used up, then the triiodide ion reacts with the starch to cause this color change. Okay? Got all of that. So there are 3 chemical reactions that occur in series. One is very slow and the other are pretty fast. And the slow reaction produces a chemical that is eaten up by another chemical. And when that chemical is used up, the iodine reacts with the starch to cause the color change.
So it's actually next time he comes into Chelsea, he's gonna surprise you with the one that we're gonna leave it steering and you see the colors changing back and forth. Okay? So when you are making stuff in the chemical industry, you get the reactants, you get the products. If you don't remove the products as fast as possible, it could cause more damage to your end product. That's why you get stuff end up at a $1 store because they were not so good.
Okay, I'm going to need a little bit more help here. Is there another volunteer that wants to come up?
We need another person to volunteer, please.
Oh, come on up. Come on up. Okay. We're going to do another experiment with yeast. This time we're going to use hydrogen peroxide. Does anybody know what hydrogen peroxide is used for? Pardon? It can be used for cleaning. What else is hydrogen peroxide used for? Cleaning wounds. It's all disinfectant. It's also used as a fuel in rockets too. So what we're going to do is use a little bit of hydrogen peroxide. And pack this up really tight. Okay, so fill this up with 1 cup.
If you don't have a chair, you want to sit at the front, you can come because these folks have to leave early. So,
Great. Thank you. Okay, now, I'm finished. I'm going to need your help. I'm going to need 2 tablespoons of yeast. Put 2 tablespoons of yeast in here. Great, thank you. Okay. Now in yeast has something in it. It has what we call an enzyme in it. And the enzyme is catalase. And catalase is a catalyst that makes reactions go very fast, especially with peroxide. So what will happen is the catalase will react with the hydrogen peroxide and it'll make a gas. Now, do you know what hydrogen peroxide, it has 2 atoms of hydrogen and 2 atoms of oxygen. And it reacts with the catalase. And what do you think it forms? Anybody have any idea? It forms a gas. What gas do we breathe in? Oxygen forms oxygen, and it also forms water. It occurs very fast. So over here we have carbon dioxide from the fermentation reaction, and here we have oxygen being formed by the reaction of the enzyme with the peroxide. Anya, you want to come over?
Oh, sure. Yes.
Okay, great. Thank you for your help. Okay. Now, what we're going to do, I'm going to light this match. What is carbon dioxide often used for?
Soda.
Pardon?
Soda.
It's used in soda, to provide the fizz in soda, also in wine and beer. But what do we have in fire extinguishers? We have carbon dioxide, because carbon dioxide puts out fire. Okay, let's see, we're going to do an experiment here with Anya. We have carbon dioxide here, we have oxygen. What does oxygen do with fire? It accelerates it. So let's see if this works. Goes out. I guess it ain't gonna work for me. I'll have to do it again. Yeah. Let me try it again.
We do a lot of trying again at school.
Watch this, guys. Watch how it's gonna go out.
Unless it won't go again. Yeah, it burned out too much. Yeah, it burned out too much, but you can see that the carbon dioxide put out the fire, they put it into the oxygen, and cause it to flare up. Okay? Made fire, yeah. Okay. Ken, cornstarch.
Yeah.
You want to give the kids something?
Yeah. Now the job begins. From now, all the chaperones here, we got a lot of work to do, so we need a lot of help, okay? This is a real deal. Yep, come on, baby. We want them, every kid to have one of each, okay? Yeah, you got it. She can start from that side. You can give it out the cornstarch. Oh.
Do you have any more?
Better. Do they need gloves for that? They don't need gloves.
They don't need gloves for that.
If you need gloves, we got gloves small. We got napkins. It's only cornstarch, so it's not dangerous, okay? If you're gonna go to the bathroom to wash your hand, but we got that's why we got napkins here. Okay. Yeah.
Before we play with that, here's another experiment I want to show you.
Can I get a cup, please?
I have two chemicals here. I have ammonium hydroxide and hydrochloric acid. Okay? The chemical reaction that's going to occur, I'm going to make ammonium chloride and water. And ammonium chloride is a product that's used in fertilizers, it's used in medicine, it's also used in cough medicine, and it's used in batteries for making batteries work. So if you watch carefully, I'm going to squeeze these two. What's forming in the gas phase, that's ammonium chloride.
Doc, did you hear what he said?
What?
Can you say that again?
This is for the society.
We're gonna answer that question, okay? He's got two chemicals in his hands.
Two separate
Two
chemicals.
separate chemicals.
And what happens is a little bit of evaporates in the container, and I just squeeze the plastic bottles, and the gas comes out of each container, and they react to form ammonium chloride.
Wow.
So it's a very fast chemical reaction.
Smoke signals.
Each of the chemicals by themselves are heavily, highly concentrated. Everything that he's gonna do here today, you can do it at home. But this particular one, you cannot do at
You
home.
don't want to do it at home.
However, to answer the question you asked, the gas you see is harmless.
It's harmless.
That's why we decided to do it here. Okay?
Well, the gas, it's used in food. It's used in medicine. Okay, so it's non-toxic. It doesn't harm you. We wouldn't do anything that harms you. Intentionally. Okay,
Worry until you have a
now do we have the slime?
What are you doing?
The little kid.
Yeah, right here.
Okay. Has anybody made oobleck in school? What? Have you made oobleck in school? What? Oobleck. Slime. Yeah. It's cornstarch and water. Okay? What you want to do is you want to take the cornstarch, okay? Open it up and put it in this little container.
measured out.
Okay? Now, next, take the water, open it up and pour it in, and take the stirrer and mix it up. Okay? You stir it, and you're mixing it up.
What's your name?
Okay?
R-E-S-S-I-E?
Now, this is a special kind of
Your name
liquid.
is? A-L? Last name?
That's why. Okay? So the whole essence of it is about absorption.
So your first name is R-E-S-S-I? Thank you.
Ammonium hydroxide.
What you can do, once you have it mixed up,
Ammonium,
if you put your finger in it, it'll go in very easily.
ammonium hydroxide.
But if you punch it, it'll bounce off. Okay? This is called a dilatant fluid.
Did it get nice and firm?
Very slowly, the Because if you pull yourself out quickly, you can't get out. It's also like the sand, wet sand in the beach. At the beach, if you stand in wet sand, you'll sink. But if you run across wet sand, you won't sink because it's hard. Okay? So this is just like that. So we have a big tray of it here. If you hit it hard, it just bounces off. But if you go slowly, your finger will fall right up.
You know what you're making, right?
Watch this.
Watch this.
Somebody has to catch on the other side. Wow. So you can bounce it up. Here it comes. But if you just put it in here, it'll just sink to the bottom.
Why is that?
Because it's a type of fluid, it's dilating. So if you move very slowly, it'll be like water. But if you hit it hard, it'll be like a solid.
So you can bounce that off and then it won't get.
That's right.
Wow, wow.
Bounce it up.
Oh my God.
You see, it doesn't even splash.
Yeah. Wow. It goes inside.
If you can grab this. See, you roll it very fast and it feels like a solid, but then
Oh my God.
it just flows out.
That's magic. That's engineering.
See, it becomes very hard.
Look, guys.
It becomes very hard. And then I just open up my. So that's what we call a dilatant fluid.
Someone wants to try that. Show what he can do with that. Hey, pull it up. See how sticky it is? Is it? Oh, it feels like it's sinking. Yeah, touch it. Look at this.
You just mix the cornstarch and water together in about equal amounts, and you can make your bootleg, or you can call it a slime also. Okay?
I'm sorry. He can.
So the next thing that we're going to do is, have you made slime in school? Have you made slime in school? Good. We're going to make some here too.
So basically, you need all I know is that
Green and blue.
green and blue. That'll mix together in blue. When you mix that together,
We're making blue now. 1, 2. All right.
You can have some people who don't like the color.
All right, so now we can get yellow as well, so we can have all three colors. Yellow, green, and blue. Okay. All right.
Come here, everybody one, please.
So does everybody have a kid?
No. Everybody one.
All right. Everybody get ready. This is going to be a blast. All right, each of you get a top.
I still want to. Sorry.
Please watch, please.
Watch.
Pay attention, everybody.
You can do this at home too. This is Elmer's glue. And Elmer's glue has a chemical in it that's called polyvinyl alcohol. And polyvinyl alcohol is used in glue. It's also used in food. It's used in cosmetics. And it's what we call a polymer molecule. A very, very, very long molecule. It has many atoms to it. And what we want to do is use this to make the slime. So you can think of this molecule as like a strain of spaghetti. Now when you cook spaghetti in a pot, you have all of these pieces of spaghetti floating around in a pot. What we want to do is be able to attach all of these pieces of spaghetti together so that we can form a nice slime. So what I'm going to do is take this glue, it's half water and half Elmer's glue. So you can buy the Elmer's glue at any hardware store. And now, you have this, what we call a pipette. Squeeze the top of it, and you put it into this solution here. This solution contains borax. Does anybody know what borax is used for? Anybody? I can't hear.
Washing clothes.
Washing clothes, yeah. You can go to the supermarket, you get borax. Borax is a powder dissolved in water. And what happens is the borax reacts with this long molecule, this polyvinyl molecule, and it ties them all together so that we can make the slime. So what you do is you squeeze the borax in here. I'm going to do 2 droppers full. And then we just start mixing it up. Slide. So mix it up a lot for a bit. I'm going to put a little bit more in. So you're mixing it up good.
Oh no, I guess I only need one more.
And then after you mixed it up for a while, what you want to do is take it off and put it in your hands.
Just keep
Hold it up like you
mixing
just
it.
did.
Keep mixing it.
Pull it out of the cup like you
And
did.
keep dropping off the borax.
So what you have is something like this. So there's your slime.
I think I put it.
Mix it up.
at some point, you're gonna take it out, dig it out with your hand. That's why it's slime. You're gonna squeeze it, it's gonna gel.
It'll feel like slime.
You're gonna feel like slime. You're gonna put more. See, you're gonna put more. You're gonna put more. Yeah. You're gonna get it out. You're gonna put more.
Okay.
You want to do about 2 eyedroppers flow.
2 eyedropper full.
All right, Mexicans, that's all.
Stir it up good. Keep stirring it up.
It's very clumped together.
Mine is too. It's on my stick though.
Yeah.
Why does it supposed to be on the stick?
I don't know, Mom. Like I remember.
I sure don't know.
Maybe it's something, Mama, it's something in here. Wherever you put it, that's what you
You can pull it off. Put it in your hands. Oh, that's great. Take that out, put it in your hands. Take the whole thing out. Yeah. And then just knead it. Just do that with in your hands.
Yes, here.
Okay?
Show it to the camera here.
See? That's nice. Wow.
Oh, it's a nice line. Keep stirring it up.
Mix it up. So you need about 2 of those completely full.
So mine's coming together more and more. You have to just stir it for a bit. How's it coming?
Yes.
Listen, please. Listen, everybody.
Professor, excuse me, it's now Dr. L. This is the second time, many years coming back to Chelsea to do this for you all.
Thank you very much.
So we want to thank him, but the city, listen up, listen. The city of Chelsea is giving him a proclamation, and we're going to have the district councilor, District 3, Joe Pelotando, is going to read the proclamation.
Thank you very much for coming to us. Appreciate it.
Like Ronald said, my name is Joe Pelotando. I'm the district councilor in City 3. I'm filling in for one of my counterparts, Leo Robinson, who couldn't make it today. His daughter's in a championship basketball tournament out in Springfield. Cool. So I'm here to read the resolution for Dr. Donatelli. So whereas Dr. Alfred Donatelli, award-empowered professor and chair of the Chemical Engineering Department at UMass Lowell, led an interactive hands-on STEM demo for parents and kids at the Chelsea Public Library on February 23rd, 2019. And whereas this interactive demo for parents and kids is part of Black History Month series of events put together by the Lewis Latimer Society and Museum in the Chelsea Black community to help promote the importance of STEM education to youth who are our potential future engineers and scientists. And whereas Dr. Al demonstrated how to make homemade ice cream with nitrogen, I want to see that, yeah. How slime and their soup balls are made from everyday materials and ingredients. and children and their parents got to blow up balloons filled with different gases and had fun mixing up random iodine reaction. And whereas Dr. Al and his team of assistants, which include Ken Ambroya, members of the Lewis Latimer Society and Museum, Chelsea Black Community, and Bunker Hill Community College, explored the application of these beginning experience in chemical engineering, reaction kinetics, and reaction design, mechanical engineering, aerodynamics and heat transfers, emulsion, polymerization, and plastic engineering, and in weightless when astronauts land in outer space. Now therefore be it resolved that we, the members of the Chelsea City Council, wish to go on record to recognize Dr. Alfred Donatelli for his many contributions in the world of science and engineering, along with a team of assistants, Ken Ambria, the members of the Lewis Latimer Society and Museum, the Chelsea Black Community, and the Bunker Hill Community College for helping present STEM programs. I congratulate Dr. Alfred Donatelli.
Jocelyn, can you just move over a little bit that way so we get that behind you? There we go. We're going to get everybody in the picture. Ryan, come on. Okay, just open that up again, Ron, Doc. Like that. Perfect. Like that. Everybody. Right here, please.
Oh, one more over here, please.
You didn't even say hi to me.
Engineering and science, and we just hope that all of you young folks pursue a career in engineering and science and math, because we can do it, you guys can do it, and it's always yes we can in terms of furthering your education and becoming an engineer. And on that note, we'd also like to say thank you to CBC for showing up and helping today, Lewis Latimer Museum, Bunker Hill Community College. Also thank you to everyone who helped out and worked together to make this day possible. We also want to say thank you to the Chelsea Cultural Board, who is on board with us this year, and UMass Lowell, because without them it wouldn't be possible today. Thank you, Professor Al, and your wife as well, and to Ann Duffy.
Thank you, everybody.
Thank you.